Okay, so here is the two math questions, 6 and 7, from the series circuit Google form. So I drew number 6 out right here. Okay, so this is what it looks like. It's a series circuit, one pathway from the voltage source, which is 80 volts, and we travel it around. We go through our three resistors, and they're labeled 15, 20, and 5 ohms each. So the very first step, we have to find the total resistance. So in a series circuit, we do that just by adding them together. So to find the total resistance, it's 15 plus 20 plus 5, and that gets you 40 ohms. And then if we know the voltage, which is 80 volts, and we know the resistance is 40 ohms, we can just use Ohm's law, V equals IR, or 80 equals I times 40. And then if we bring the 40 to the other side, and I is going to be 2 amps. So that is the answer to number 6. And then number 7, set up the same way. So it starts off, okay, we have our series circuit. So we're going to first find the total resistance, and then we're going to find, after that, the total current in the circuit. So to find the total resistance, we're going to add up our three resistors. So 1 plus 2 plus 2 gets us a total of 5 ohms, and we know voltage is 12 volts. So let me write that next. So our total is 1 plus 2 plus 2, which is 5 ohms. We can use V equals IR. So V equals IR, or 12 equals I times 5. And if we divide both sides by 5, I is 2.4 amps. So that's the first part. All right, I think the confusion is more in the question than the actual application of how you do this. So the other part was, can you find the voltage across each individual resistor? So here's what we know about resistors that are in series. Okay? We know their voltages are different across each one, but their current is the same. So every resistor has 2.4 amps of current running through it, and we know their individual R values, 1, 2, and 2 respectively. So if we use Ohm's law, V equals IR, we can solve for the voltage of each one by plugging in the current, 2.4, and multiplying it by the resistance. 1 for the first one, and then for the second two, the resistance is just 2 ohms and 2 ohms respectively. So if we do that, for R1, we ended up with V equals 2.4 times 1, which is 2.4 volts, across resistor 2 and resistor 3, we're going to get the exact same values because the resistance is the same. So it's always the same current because it's a series circuit, and just multiplied by those resistors. And we end up with 2.4 volts across resistor 1 and 4.8 volts across resistor 2 and 3. That is the potential difference on each one. And as a little way to check your work, if you add these three together, you should end up with the same voltage as the overall voltage in the problem, which was 12. So 2.4 plus 4.8 plus 4.8, that is also 12. So it's another way to check your work. So that's how you do that last part.